Hi, this is Andrew Nightingale. I'm here to teach about the logic puzzle program which I created. The first thing to notice is that there's a help message over here, and when I move my pointer around on the screen, it tells you a help message about where your pointer is pointing at. The first thing I want to show is the green puzzle piece, which on the right, as you can see, says the green puzzle piece is your proposition A, B, or C. These can be anything you want to assert, such as ravens or black. So, and you can see where you want to drag them to these empty slots. So I just constructed A, and this graph here, it talks about it, this is developed by C.S. Peirce, uses only the circle symbol. So and the circle negates what's inside. So we have not, what's inside, not A. Not A is the same as A. And then you can make it a true Peircean graph by clicking this check mark and getting rid of the A. It still means the same thing. So I'm going to play around with constructing propositions. Here I've just constructed A and B on one side and A and B on the other side. Next I want to show about the blue puzzle piece, which is used as a parentheses and as a negation at the same time. So that's really the circle part of the program. So when I do this, when I put parentheses, there's a left one and a right one. When I put parentheses around A and B, I get one circle, which goes around both A and B, the same way that the parentheses go around both A and B. So here I have not A and B, and on this side I have A and B, so I have a contradiction, and it detects the contradiction and switches to pair-consistent logic. So here I have something to say about the pair-consistent logic in the help. It works just like a regular truth table, except it adds a row every time an entry is both true, 1, and negated. So I have A and B is true here, within the situation where B is true and A is true, and then it gets negated over here, and it splits into two rows. One situation where not A and B is true when A and B is true, and another where not A and B is false when A and B is true. And then you can see the final row, the final column has this statement and this statement linked together by and it can be true in the situation where not A and B is true and A and B is true. So that's what I have for classical logic, and the point here is to show students that there is more than one kind of logic, and it's in answer to a problem that may occur when students learn classical logic, that they may come away thinking that that's the only or the correct way of thinking. And so this is to show that there are other ways of thinking, and also that there are ways of thinking that computers can do. So computers are not proof that classical logic is the one true logic. Computers can think in other logics as well. The next thing I want to show is the constructive logic window. Here I have the same thing. The green puzzle piece is A, B, or C. Only now I tell you what A is. Before, A could have been anything. But now I say, okay, A is a ring. It's made of straight lines between nodes. All nodes must be part of the ring. And the outer angles at nodes of the ring must be greater than 180 degrees. So the outer angles are greater than 180 degrees. All the nodes are connected in the ring. And that's A. So asserting A means that A is constructed. This is its constructive logic. Asserting not A means that A is not constructible. So the blue pieces work the same as in the classical logic, only negation works differently in constructive logic. So here, A cannot be constructed because to get all the nodes into one ring would involve one angle being smaller than 180 degrees. So A is not constructible in this situation. And I have more to say about negation. If I mouse over the negation puzzle piece and the parentheses puzzle piece, I have A means A is constructed, not A means A is not constructible and not constructed. Not A means A is constructible but not constructed. And then not A is the same as not A, so it collapses after that point. The next thing I want to show is the OR statement. Now the OR is different for constructive logic as well. It doesn't hold a true or false value the way a normal classical OR statement like A or B would hold. Instead, it holds two values. The first value is which side of the OR statement is being asserted. So if it's A or B, the first value of this statement is A or B, depending on which is asserted. And the second value is how to construct the side that's being constructed. So if A is being asserted, the second value is how to construct A. So let's build an OR statement here. So it prompts you, this is how to deal with the difference in OR. So it asks you what A is. And I'm going to say A is true. And I get this graph. So I have the statement not A or B. And since A is true, this side of the statement can't be asserted. So that means B is asserted. So this statement is the same as the statement A and B. And we can see that A is true because we have the same set of it still follows these rules where the outer angles are greater than 180 degrees. And then B is a star, rays emanating around a central point, and all the nodes have to be part of the star, and so we have A and B. And that's all I have for this presentation. Obviously, there's a lot more you can do with this program to explore the different logics, and one of the important parts is that it doesn't make you do any of the calculations. It does the calculations for you so that you can just get a feel for how constructive logic, paraconsistent logic, and classical logic are different and related. So I want to end by talking about the AND, which is the same as classical logic, and the if-then is over here. So D, I only do if-then for D. D is the only thing that is implied. And D is a rectangle. And the way implication works in constructive logic is if you construct, say in this case, not A or B, D is implied when, as a side effect of constructing A and B, you get D, a rectangle. So here, the rectangle is constructible but not constructed. That's the same as not D. So this logical statement that we created implies not D. And that's it for the introduction. I hope you have fun with the worksheet. Thank you.